Hello, everybody. My name is Robert Starmer, and welcome to Next Gen Cloud and DevOps Automation in 2020 and beyond. In this webinar, we're going to talk about Kubernetes, microservices, the DevOps movement, really looking at how all of these technologies have changed our lives and the context in which that change really makes sense. Maybe you shouldn't be doing DevOps is maybe part of the conversation that we want to have today. I run a technology consultancy, and we focus on helping people make this transition. I'm joined today by Syed. Syed, why don't you introduce yourself?
Yeah, hi. So I'm Syed Rashid. I work for Red Hat. I'm the Cloud Native Solution Director for Cloud Native Solution Director. So my job is to educate our customers about this new way of building applications and running IT and delivering IT services.
And Tarek, why don't you introduce yourself?
Sure. First of all, it's a pleasure being here. Robert, thank you so much for hosting the discussion. My name is Tarek Modi, and I run a company called Tech Nirvana based out of Washington, D.C. We do consulting for both the federal government as well as for commercial companies, focusing on agile, DevOps, cloud native applications, cybersecurity, big data, and so forth. Most of these solutions are geared towards IT modernization initiatives, and that's something that I would like to be talking about today as well. As mentioned, when should we be doing these things? And more importantly, when should we not be doing these things, and maybe looking at other alternatives?
Right. Very good. So I think one of the first things, in my technology or in my company, we look at sort of the four pillars of getting to cloud. We look at strategy and then define what architecture makes that strategy happen. And then we of course look at implementation and even education, sort of the post-delivery kind of enablement. And one of the first things that often comes up is people say, oh, the latest buzz right now is cloud native. We have to do cloud native. We have to do containerization. That is the answer to all of our problems. And if we can just get there, we're going to be happy. And in fact, we've started our containerization. We've built containerized things. I find this is sort of an interesting response because for the most part, containerization is maybe an answer. I think there's a lot of value there personally, but it's not the only approach. So maybe the first question, and Syed, I'll let you take this as a lead. What does cloud native really mean? What do you find people really understand when they say, hey, we want to do a cloud native thing?
Yeah, so let me start by just, instead of, just give you a straight definition. This is our, our perspective on what is cloud native. In very simple words, it's an application delivery discipline, and by delivery we mean development plus deployment, to handle constant change that's happening in the market and take advantage of cloud computing anywhere. So in this definition, there's a couple of hidden things. A cloud computing anywhere, that means it's not related to public cloud. You could be doing cloud native development or cloud native app within your data center if you run your data center like it's a cloud. So you have adopted, you have elastic scalability capability. You have automation built in there and things like that. Actually, so now I want to kind of expand on this definition. So why would anybody care about creating an app this way versus past approaches? So some context. I think the past approaches can be summed up as focused on reuse. So we were very, concerned about how if you're building a service, how are we going to reuse it? Which means that you have to become very good at predicting the future. This is the crux of the discussion. In the past, we spent incredible time, energy, money trying to predict the future, predict future business model, predict what customer wants, predict the best way to design and architect a system, predict how to keep applications from failing, etc., right? So instead of trying to get better at predicting the future, we want to build a system that gets better at responding to change and unpredictability. And this is what we call cloud native. And this system is made up of people and is delivered through technology. So that's my.
Okay. All right. So I mean, if I were to do a quick summary, and Tarak, I'm going to ask you for your version of this as well. You know, the first thing I heard was Elastic and automation are sort of a core set of tenets, right? Elasticity, and I think I used to talk model a lot. So from 2010, 2011, right? The National Institutes of Standard and Technology in the US, I mean, I know we're a worldwide audience. So those folks tried to define for our federal government here in the US a model for cloud. And I know that elasticity was one of the key components, because at the time, at least, and I think even still today, people implemented resources. They said, yes, we're going to go to a virtual environment. We're going to go into this new cloud-like thing, and we're just going to consume resources that way, because now we have an automated way of consuming those resources. But they forgot about giving them back, right? So I think that elasticity is really a key in making any of this happen. And I agree 100% that without automation, we really don't have. Those are our core tenets. Then from there, I think we do get to something that looks cloud native. Tarak, what are your thoughts there? How do you look at cloud native? What's your definition for this space?
So first of all, Syed, I really enjoyed listening to your opinions on cloud native, and particularly when you talked about previously we were too focused on sort of predicting the future, trying to create a service that could pretty much respond to any situation that came about. And I think that's probably one of the reasons why service-oriented architecture wasn't as successful as it should have been. Because when you think about it, a lot of the principles that we're talking about nowadays with microservices and cloud-native architectures, while the technologies are definitely more advanced nowadays, the principles were something that we were talking about even 20 years ago. Or 25 years ago, with web services and SOA and creating this architecture where everything was supposed to be coupled. It wasn't a monolithic application. And initially, I think we were making really good progress in that direction. But then you see ESBs, like enterprise service buses, and all these big players coming in and trying to introduce new products into this space. And we all of a sudden transitioned from thinking about loosely coupled systems to trying to predict everything and creating these architectures that could respond to no matter what the situation was, no matter what the industry is, no matter what's going on, it should be able to respond to everything. And we ended up going back into this monolithic architectures, right? Where the SOAs basically became sort of components of this monolithic architecture. The same thing's happening with the transition from waterfall to agile. With waterfall, you're always trying to predict the future, trying to anticipate everything that you're ever going to need. Whereas agile is all about creating processes and infrastructure where you can respond to change. And the same thing is happening with microservices and cloud native architectures. You know, it's about creating these containerized microservice-based architectures that don't really try to anticipate everything. They're independent, they can be deployed, used, and if you need something else, you create another microservice. And so I think ultimately it's all about moving to where we were trying to move to about 20, 25 years ago. And this time not repeating the mistakes of the past.
So make SOA work is what you're trying to say, right?
I really think that this is, you know, it's sort of like cloud computing. You know, we were centralized, then we became decentralized. Now we're sort of centralized again. You know, it's sort of like we're rediscovering the past, but let's make the past better by not repeating the same mistakes.
Yeah. Well, you know, we could just jump ahead and just say, you know, the cloud is dead, long live the edge, right? I mean, isn't that the next big push?
So now we're going back to decentralized, edge computing and fog computing.
Yeah. Well, but I think actually it's kind of interesting because I've seen that message be thrown around. Oh, it's like cloud computing is, cloud and centralized cloud is the end. It's reached its peak. It's the zenith is gone. Everybody's doing containers and agile, so we've got that one handled. So now we're going to just move everything to the edge. It's going to sit on your phone instead of, or I guess in the cell tower instead of on your phone. But we're not going to have data centers anymore. We don't need those things. I think that misses the point. From my perspective, as we're talking about the cloud native model, cloud native can be at the edge, certainly, but the reason it can be at the edge, I think, is because we've seen this shift. We've seen a push towards an organizational change in how applications are developed. I mean, if we think back 10, 15 years ago, even most infrastructure, and honestly, still this is true today probably as well, but most infrastructure was handled by domain-specific groups. We had the network team, and we still have the network team. We have the storage team. We have the compute team. And there are still plenty of organizations that I talk to, I'm sure you guys as well, where in order to get access to compute resources to do development or productize a concept, you still have to ask IT. You still have to ask those towered resources that, hey, I need this particular capability to go make a job work. But this idea that we can get to containerized microservices, that's the answer, is I think a part of the solution, right? That's the architecture that enables this. I think the question still is, what's the strategy that's driving that for businesses? Right. I think we've all seen it. We go in and somebody's already we've done a containerization process, but it hasn't actually achieved the business goals. Right. The organizational shift hasn't happened yet to enable that. The mindset shift hasn't happened. You're still doing waterfall development, but now you've containerized, and so you've fixed all the problems. Right. You can't release on a daily basis or even a weekly or monthly basis. Well, the waterfall process doesn't finish for 9 months, right? How do we get from the concepts? Because I think we've sort of defined it, right? We've said, elastic and agile. I like the idea, don't predict the future, right? We can't predict the future, but we can develop things that allow us to agilely get to the future, right? Mm-hmm. But how do we then deal with that organizational shift that is needed? How do we make sure that our strategy actually aligns with the business needs? So, I mean, what are you seeing in that space? How are you seeing people approach that problem and get to successful cloud native?
Yeah. So we talked about elasticity and future and predicting the future and architecture, but we are forgetting one of the most important tenet of cloud native, which is really the DevOps process drives it. So the whole idea of this idea of separation of concerns, distributed responsibility, actually it goes down to, hey, operations teams, make sure that platform is always ready, always available. The environment is always available to developers. And then application teams really then own the responsibility for their application to run on that platform. And they own end-to-end responsibility, not just, hey, I wrote the code and I'm just going to throw over the wall, but rather I am going to be responsible on if my service failed, that I have the built-in capability to isolate the error, what happened, what went wrong, that I actually have, I can actually go back and recover from a service, or if they introduce a new feature, that they actually do their experiment in a way that it does not bring down the entire system. So, and that's what, that whole thing is actually what I would name the DevOps. Is basically the process of taking an application from development to testing, to acceptance testing, to integration testing, to ready for deployment. And then, sometimes some companies are really advanced and they go straight to deployment into production. And that's the whole cycle. And that cycle has to be extremely predictable. It has to be extremely automated. So you could actually restart things if something breaks in the middle, that you could recreate something and you can restart things. In fact, when I go to several of my clients, one of the things that I ask them, they are always excited. We want to do microservices, we want to do this, containers and things like that. I usually ask them, how long does it take you if you make one line change of code, how long does it take you to put it in production? And if their answer is 3 months, then I say, first fix that problem, because you're taking too much time to put into production one line change of code. So, and that's the key. The DevOps becomes it has become the new way of delivering business value, and getting all the teams organized on this common goal that, hey, we are all driven by outcomes. Mm-hmm. The outcome is we need to be able to push applications out, applications out in a more consistent, predictable, reliable way, but do it without wasting a lot of time.
I like that. I like that line. How long does it take you to get a line of code into production, right? Because I think that helps people differentiate I'm doing waterfall, and even though I think I'm agile because I've gotten to containers, right? Because I mean, I think it's dangerous to define cloud native as containers, right? Because I can containerize a Java app and end up with a 10 gig container, which really does not work well with a lot of the cloud native workflows, because you just can't deliver that quickly, right? Yep. But if I can deliver a line of code in a reasonable time, and I guess the question is what's reasonable, but the faster the better in a sense, because if you can do it quickly, if you can do it within a very short period of time relative to your classic development paradigm, I think you've really made a lot of successful things. You said another thing that I think was kind of interesting, because we said, hey, don't predict the future, but we do need predictable deployment models, right? Yep. And I'd like to know how do you differentiate between those two concepts, right? Because one is, I think, looking at the gross picture, right? How do I get my application to production? Well, I'm going to predict what that application is going to do. Full time frame, 6 months. Right?
Yeah. Maybe the words that I chose, predictable, is more reliable. So basically, have guardrails. Does not mean bypassing a lot of governance rules, a lot of safety nets that you have. You just have to be careful that each safety net is, like, I'll give you another example. I actually talk about when I go and there's a lot of waterfall, talk to IT operations team quite a lot, and they're like, no, if you're going to push change so fast, it will break and all that stuff. And we talk about, like, okay, so let's talk about all the gates that you have put in. How effective are they? Have they been, how many times have those gates in place actually caused them to actually be activated, that you found something and you rejected it? What we have found, that when we talk to customers, that when you look at all their gates and how they're performing, their gates are there just to add time. Never have they ever had any gate reject anything. So it was just adding the contingency time to their.
Well, yeah, it's let me put the human back in the loop, right? So we have tools now like, there's the whole new foundation from Linux Foundation, right? The delivery foundation, or container. I don't know, CDF. I don't know what it stands for now off the top of my head, right? And I know there's Spinnaker and a couple of other tools in there. And I've worked with Spinnaker for a couple of companies recently, and one of the biggest problems is, what gates do you put in? Where do you automate a gate, or try to define an automated test that drives a gate? Whether it's in the continuous integration, sort of the early of ops, or the later phases where I want to do full-on delivery into production. For my pipelines, how do I manage resources? Tarek, you've been a little quiet here for the last couple of minutes. What are your thoughts here? I mean, again, I think we've defined that maybe there is still a separation, and as you sort of look at that organizational change, the differences in how you implement cloud native processes, there is maybe still an ops organization that maybe has infrastructure ownership, so it's like the silos aren't completely gone, right? And that migrates into this interaction or intersection between ops and applications. And what are you seeing in terms of people's transition from the classic waterfall monolithic application and development into this container focused microservice focused development? What makes that work for somebody? What is the strategy by which that kind of transition can work for your customers? Is there one?
I think your question. I think your question is actually going to be longer than my answer.
Uh-oh.
I think the question was like 3 minutes long. But anyway,
try to paint a picture here.
Yeah, I'll just ramble on. That's okay. So I think one of the reasons I was so quiet is because the discussion was actually really interesting. There's so many different points that were brought out, and I can think of like so many things I want to say. Like for example, with the stage gates. Yes, I think they definitely need to be automated. And I think a lot of the stage gates are just there to add value. But I also think, playing devil's advocate, that a lot of times you don't discover anything in these stage gates because they are there and people know what's going to be looked at. And so they are ready for that. And that's one of the reasons you don't find defects in those stage gates. There was a study done in production engineering where just the fact that you think somebody is watching the assembly line reduced defects significantly. Whether or not somebody was really watching the assembly line or not is not relevant, but the fact that the workers actually thought that they were being watched actually played a significant role in reducing defects. And so just by having stage gates in there and well-defined checklists for each stage gate might never activate the stage gate itself, but it's probably going to be effective in reducing defects and rework. But yes, these stage gates definitely need to be automated, because I have been in many organizations where stage gates are very manual. They involve too many people, and it just takes too long to get through the stage gate itself, and it's not, the value it's providing is not worth the cost. So that's stage gates. So going back to the initial question about, what's the value, like, what's the business value in all of this? And I really think that when we talk about IT, a lot of times the whole discussion is based in a incorrect paradigm. So we talk about business and IT, or we talk about IT being aligned with the business. And I think both those are incorrect ways of characterizing IT, because IT is the business nowadays. You may not be an IT company, but a lot of your delivery, a lot of your services are based in IT. You take UPS, FedEx, they're not IT companies, but their value that they bring to the market is based in IT. They are truly IT-based companies. And so IT is not a separate concern. IT is the business. And that's the way all of us need to think, not only the business folks, but the IT folks as well. When you look at security, for example, cybersecurity, you don't secure each application the same way. Not every application is going to get the same level of disaster recovery planning and the same level of contingency planning. You perform what's called a business impact analysis, where you look at each individual application and you figure out, based on the business value that this application is providing, the criticality it's providing, what is the right level of security that you need to provide. You don't protect something that's worth $10 with a $100 lock. It doesn't make any sense, right? The same thing goes for microservices and containerization. You need to make sure that the applications that you're selecting actually warrant containerization and microservices. The applications have to be large scale. They need to be inherently stateless. They need to be preferably web-based. There needs to be a business supported need for taking it into containers and microservices. Before the panel, Robert, you and I were talking, if you have a business application that's only deployed once every 2 years and that rarely changes, it doesn't make sense to have a full drawn agile process and DevOps infrastructure for that application, right? I mean, it's just not the right use of your resources. And then you look at people, process, technology. People, you need, Syed talked about this quite a bit. You need to have the right people in the organization. You can't have these silos. Nowadays, the trend is instead of having T-shaped, I-shaped people, you have T-shaped people where they have a specialty, but they're broad-based and they understand how different groups interact with each other. DevOps is, that's a prerequisite for doing site reliability engineering. DevOps is having people who are cross-functional and can function across different areas. They're more T-shaped. Having the right training in place, making sure that these skills are continuously updated. From a technology perspective, you need to make sure that you're considering all of your enterprise integrations like SSO, and making sure that you're staying pure to your technology selection. You're not locking in unnecessarily with different vendors and different stateless architectures or serverless deployments. And then finally, your processes. You need to understand that as you're making this transition, you're going to fail. There are going to be hiccups, and that's the whole reason why agile and iterative development are so successful. Is that you discover these things early on, learn from your mistakes, and you move on. And so, start with a pilot project, select the right application, make sure you have the right people on the team, and then take small steps. And once you have success, move out from there, fan out from there, select more applications, migrate, move, involve more groups in this. Don't start, try to boil in the ocean. Start small, get your successes, document the lessons learned, and then move on from there.
So I actually have a question sort of based on that. I mean, you pointed out that, and we sort of talked about the fact that, yes, microservices and the containerization of applications isn't necessarily the right answer for everybody. I've seen some applications, though, that containerization is a nice way of packaging the application. It's not so much that containerization only works for microservices. So I think it is worth at least considering the fact that there might be some business practice, even if you're not ready for cloud native, right?
Yeah.
Which again, I think is a fully automated, delivery pipeline driven, cross-functional team managed application environment. If we think of it that way, right? It's more than just containers. I used to work a lot with the OpenStack technology, and it still comes up from time to time. One of the most interesting things there was that was a set of applications. They were effectively individual monoliths. Yeah, they were actually communicated through APIs of a sort, but it really wasn't quite as segregated and truly microservices I think we'd wanted to get to, and maybe is now getting to over time. But one of the interactions, even though those resources were only upgraded every 6 months, or maybe even every couple of years, the biggest interaction was the individual components running on the same hardware, on the same infrastructure, breaking each other. Right? You tried to update the authorization management resource, and it broke your compute management component, right? So I think there's tools that even if your company isn't yet ready to make that leap, isn't ready to allocate a person as an SRE or make that cross-functional team come together, there's still values that you can pull out of that cloud native space.
Yeah, absolutely. I completely agree. And it's never that cut and dry. So what I typically do is I love maturity models. And you have to sort of take a maturity model approach. So with microservices, for example, with clouds, you can have applications at level 0 that are just not ready for the cloud at all. At level 1, you might have applications that are compatible with the cloud. Level 2 might be an application it's not fully cloud ready, but it's something that can leverage cloud capabilities. And then at the highest level, you have applications that are built ground up for the cloud, like your cloud native applications. And the same thing applies to microservices or containers as well. You have a spectrum from applications that just do not belong in a container to applications that could benefit from the container, could leverage some capabilities of a container, or are just fully built for the container. So yes, it's never as cut and dried, but I think the point to remember over there is really understanding and communicating to everybody what exactly the benefit is that you're trying to achieve from that transition. So if you have an application that you're just moving to the container because it's going to give you better packaging and deployment abilities, that needs to be communicated and documented so that, you know, there's not misconceptions about what that is going to give you. And there still needs to be business value derived from that as well. Again, if it's an application that is only deployed once a year or once every 2 years, is it worth the effort of doing that at all, even in that case?
Yeah,
Right?
yeah. I think we have to look at that. So one of the things that we had sort of wanted to talk about, I think, is what is you know, what is the process for, and we've started to talk about it here, even Tarak, but maybe Syed, what are you seeing in terms of process to get to? So let's say you've allocated or you've defined an application space, something that's maybe even already started to become, you know, start with a 3-tier application. You want to start breaking that apart because you want to build out an authentication service, or you want to build out an additional resource that is a clear separation into a microservice-like space. What are some things that you see people doing as they start saying, "Oh, we're going to use APIs to communicate between our resources, and we're going to start containerizing the applications. We're building cross-functional things." You know, so we're starting to do all these things that we've been talking about. What are some of the things that you're seeing people do that they probably shouldn't be doing? Right? What are some of those anti-patterns in the cloud space? And actually, just before I let you answer that, I do want to let the audience know this is live. So if you do have a question and you're on the BrightTALK service, you can ask us a question. We will see that question and hopefully be able to answer it before the end of the hour is up. But again, so going back to the question itself, what are you guys seeing in terms of anti-patterns, things that you really should say, hey, that's not only is that not cloud native, but that's approach to what you're trying to accomplish?
Yeah. So let me start by what we are seeing right now is there is this desire to create new applications faster or create applications in a timely manner. And timely manner is dependent on every organization. But every IT organization also has to deal with existing applications. They don't want to just retire all of them all at once. So there is a priority. They set priorities on what are they going to do with it. Are they going to, because like we were talking earlier, containers actually do have a play. You know, you can use containers to host a monolith just because containers are operationally more efficient. They take, you know, it takes much more quicker. You can spin up a container and host a monolith than and your server utilization, you can host a lot more containerized monolith on a server, a hardware resource, than a virtual machine. So we have seen, and then there are some applications that are actually, when they were designed with 3-tier or N-tier model. They were very modularized, and now people are seeing, like we see a lot of e-commerce application being converted into, okay, this was an N-tier application that was all packaged as monolith, but eventually people are breaking that apart because different functionality needs to have different functional or performance requirements. You know, recommendation engine or search functionality gets called a lot more than the catalog display functionality for e-commerce applications. So I'm just giving it, so then people think about, okay, we have to kind of add a new, decompose that, breaking the monolith, maybe use a Strangler pattern or something like that to break that monolith. And
why don't you describe that? Because I'm sure there are plenty of people that don't know what a Strangler pattern is.
Yeah, so Strangler pattern, actually, I think it was ThoughtWorks actually came up with that one. So the whole idea was that people have been writing modular application for a long time. It's just that it was layered and it was all packaged in one. So the Strangler pattern is basically breaking that apart, adding a service layer, and be able to expose different components or modules as independent so that they can run independently. and you can scale them. You can basically apply different operational policies independently to them, so they don't impact. You have less impact on that. So the Strangler pattern is basically repackaging or reconfiguring applications with a service layer or API facade to basically make it more loosely coupled, more modular, and be able to operate more effectively that way. So that's what we have seen. In fact, one of our customers, very large financial institution, they moved from virtualization to containerization, not because they were doing anything with cloud native development. All they did was, hey, we want better server utilization and we want to save cost. And even like Red Hat IT itself, we used to use virtualization for our 2 data centers within US. And we moved to container, we moved our applications to containerization. And because of the way how containers actually behave, utilize less resources, things like that, we moved from a disaster recovery scenario where we had an active passive data center. We went to active data center. We had applications actively serving clients in both locations, and they were mutually failover for each other. So we have seen that. Now, in terms of anti-patterns, what we see is it's like with any other technology. You see this, Kubernetes is really hot. It's one of the most engaging community out there. So a lot of what we see is people get into, oh, I can just go and download Kubernetes, and then they realize that they need a lot other community projects to make it work like a platform. And they start doing that plumbing. And before they know, they are actually have deviated from their, like what Tarek was saying, they deviated from their main objective of producing application to advance their business. They become in the business of developing platforms. Yeah. And applications have become a sidetrack issue. So that is one of the number one anti-pattern we see. I go and say, look, Mr. UPS. In fact, UPS is one of our customers. You are in the business of digitizing your business. You want to use technology to advance your business, but in order to do so, you should rely on a specialist like Red Hat or IBM or other companies to, provide you the platform. And you should really invest your energy in learning that platform, or how to effectively use that platform to produce the application. Absolutely. Instead of inventing the platform itself. So that's number one. Number two things that I have seen as an anti-pattern is also in the area of decomposition. Sometimes, remember in old days, people, in database design, there was a third normal form, which was the most optimal form, but it was one of the most difficult to work with. Right. Because it decomposed too much. And that's what we also see, that people, when they go to the decomposition phase of breaking their monolith into microservices, that they become over jealous.
Yeah, well, I think even the in the ThoughtWorks, I think of it as the ThoughtWorks book, the sort of like the microservices Bible, right? Yeah. One of the early anecdotes is about that exact process of saying, oh, we're going to build this new app and it's all going to be microservices, and they start. And it's just they've gone too far, right? They've made too many little services rather than thinking about how the application works. Yeah. I like the comment that you had though about the positive pattern of thinking about sort of wrapping those resources when you do start to see the modularization, when you are taking your monolith and trying to break it apart. Maybe you are trying to get to Kubernetes because you're hoping that that's going to give you a better management paradigm, right? That's the real value of Kubernetes, anyways. It simplifies that infrastructure management out of the application domain but it gives you the ability to potentially way over engineer things, but also it gives you the ability to really think about which components should be separated out. And I do agree with you. You know, moving to Kubernetes is not just moving to Kubernetes; it's moving to a completely different infrastructure and structure. Tarek, to sort of get you back into this conversation, and maybe at the same time try to address one of the questions that the audience has thrown out. You know, the question was, you know, how do we how do we transform continuous delivery process to a continuous deployment process? Is containerization, Kubernetes, are these the tools that we need to use? You know, is there a pro pattern, or even is that concept maybe an anti-pattern? Where do you see that? You know, again, I'm going to make these complex questions. I'm going to make them even worse.
So before I get to the question, I just want to talk about the anti-patterns a bit more. So the two anti-patterns that Syed mentioned, I definitely agree with. I've seen this as well, where organizations in their zeal to move to a platform like Kubernetes try to do everything themselves, and eventually, you know, they're spending way too much time on configuring the platform than actually what they're supposed to be doing, which is creating the applications for the business. So yes, that's definitely a valid point. I completely agree. Agree with the second anti-pattern as well. The third one that I would say that I've seen is, and I talked about this briefly, and this sort of builds on what Syed said as well, is avoiding vendor lock-in too early in the process. So even though you're not in the business of building a platform, you should at least have that architecture in place. You should have a broad understanding of what your platform is to do, and not solely rely on a company like Red Hat or IBM or any other company and just get completely tied with them. And then your business is now constrained by the constraints that their platform have. So all you can do is what the capabilities they provide. If you need to do something that's different, now you have to work around that. And now all of a sudden the platform becomes an artificial constraint in your business. So it's always good to, while you don't have to do everything yourself, at the same time, you don't want to be too heavily reliant on any single vendor as well and just get locked into their platform.
Yeah, and I'm pretty sure Syed wasn't trying to imply that you should only go use Red Hat as a vendor, but I do think I think you have a point there, right? Which is that, you know, the platform is important. Don't make the platform the thing that you're doing. Your thing is still your application. I think vendors like Red Hat and IBM, even today, are mostly moving people towards this model of Kubernetes as a platform because it gives you a vendor unlock effectively. Right? It says, look, there are lots of targets where you can place that. You can use some of the private offerings, which are effectively now Kubernetes based, you know, or you can use a public offering, the same backend, and that gives you flexibility. And I think, you know, sort of trying to answer that one question from the audience, you know, Kubernetes is a tool that enables that. That enables that capability, right? It's a part of this set of resources, and it's not just Kubernetes, unfortunately. It is a lot of other pieces that you really have to put in place to make it work. But how can you make sure that as you're getting there, you're not becoming a Kubernetes platform company? Instead, you're building an application that happens to leverage this very interesting and powerful platform.
Yep.
Right. And I I did not answer the question that was asked by the audience, and I just wanted to spend a couple of minutes talking about that.
Yeah.
So there is a distinction between continuous delivery and continuous deployment, and depending on the criticality of the application, it could be really seamless between delivery and deployment. And in the case of mission critical applications or applications that have an impact on somebody's life, liberty, it could be a very huge distinction between actually delivering software and then deploying it in production. And it's not really about the tools can facilitate that, but that's when the processes and these gates become really important to make sure that when you're deploying something in a production, you're fully confident that it's going to satisfy the needs, that it's been fully validated as to performing the functions that it needs to perform. So tools can help you, but that's definitely where the processes and these gates become very, very important.
Yeah.
Yeah, so it's a good point that the processes really are more the value than the tools per se.
Yeah. Actually, the continuous delivery and continuous deployment, that's a business decision. It's not a technical decision at all.
Yes.
It's actually, do you want to push this live update to production, or do you want to hold it, it's ready to be deployed, but you want to hold it just for some safety net?
Yes.
So it's a business decision. It is not, it has nothing to do with technology.
Exactly. I completely agree with that. Very well said.
Yeah, no, I agree as well, and I think it's interesting because again, it's not about the tools, right? So Tarak, as you pointed out, it's more about what are you trying to accomplish and how can you accomplish it. Now, the interesting thing is that you say it's a business decision, and it might be a business decision to say we're going to go to a continuous deployment model. But you still have to be able to support that, right? Because if you don't have the right processes and the right models in place, we talked at the very beginning of automation being a core aspect to this, and a reliable path to release, whether that's continuous delivery release or continuous deployment release. Once those processes are put in place, then I think you can start thinking about, is this the right business decision for the company, right?
Yep.
But you still have to have those tools, and I think this sort of comes to the real crux of this entire conversation today, which is, what is the cloud native mindset? What is that process? Is there a definition, which I think we've again sort of bringing this full circle? Is that definition just automation and elasticity? Is there something else that we should be thinking about? And rather than defining cloud native as containers and microservices, is there a better way of describing the business process versus the technology process for cloud native?
So,
right?
I'll go first this time, Robert.
Yeah.
I think the way you brought this back full circle, I mean, it's really the crux of this discussion. And so many good points have been made during this discussion about, automation and tools being secondary, processes being the drivers, taking a look at the business needs and the business value. And again, I'll go back to something similar that I said earlier in the discussion, which is, we're not really trying to do new things over here. The thoughts have been around for a while. Back in the early 90s, I don't know how many of you remember Michael Hammer, but he was famous for saying, don't pay cow plats. So what he was trying to say is, as part of your automation, don't just take a process that you have today, some manual process, and just insert a bunch of tools in it and automate that same process, because that process may not be the optimal process. Whenever you're trying to move to a new technology, in a new technology direction, or adopt a new strategy, you really need to question the core. Why is the process the way it is right now? And is this the correct process that we should be following? Forget about the tools. Take a look at the process itself, redesign the process, go through that business process re-engineering phase, and then insert the tools where it makes sense. The same thing applies with the cloud native, or DevOps, or Kubernetes, or any of these things. It's all about making sure that you're evolving your business processes and your strategy lockstep with your business value and the needs, and then using the tools as necessary and as they add value in the right places. If you don't have the right processes, no amount of tool is going to fix a broken process. And in fact, it's just going to make the problem worse, because you're going to get the errors and the issues more quickly. So instead of having the error every 6 months, you're going to have an error every 2 days when you deploy. So,
yeah, I mean, one of the things I remember people always talking about was breaking the build. Right? It's like, oh, we broke the build. Well, I kind of wonder if that should even be a thing these days, right? Should you ever get into a position where somebody has broken the build, right? because the process is changing. There's actually a question that somebody's trying to understand: DevOps versus containerization. Are they the same thing, or are they not? Right? I think that, from my perspective at least, they're not the same thing. DevOps is a process model for how software is built.
Right.
And it integrates the operations and development. And actually, I have a whole. I could talk for hours on the fact that I think that there really are still two separate things, but I'm sure we could as well, right? But I do think that containerization has, in a sense, confused the situation, right? Because people now suddenly think, oh, cloud native and containers and DevOps are all one thing, and I have to do those things. Right, as Tarak, as you I think so eloquently been pointing out, it's more about what is the business process that you're trying to accomplish. Here are a set of tools, a set of process models that we can start to implement and integrate into our environments. And said, I mean, from what you're seeing, are you seeing similar sorts of things, or did you have any counter arguments to this direction?
Well, I think I'll reiterate what we when we started about predicting the future. The whole idea how to anticipate customer demand, the market fit. The only way to do that is through experimentation. And you need to start thinking about what are the capabilities do I need to safely do the experimentation, not be risky about it. Be able to test some hypothesis, get feedback, but do it in a safe manner. And that's where I think the cloud native is really it's all about is what's essential in terms of capabilities and practice in a cloud native approach. For example, what are the capabilities and practices needed to make it economical to work in a small batches? And small batches is basically microservices or test hypothesis and learn. Capabilities like cheap application builds, safe deployment, automated management of deployments, start, stop, scale, health check, security, distributed configuration, traffic routing, and other capabilities. So this is where, instead of associating, containers equal cloud native or DevOps is equal to cloud native, I think cloud native is, like I said, it's an application delivery discipline. The key attributes are it uses DevOps as the process. It leverages these technologies, containers and orchestration and microservices. But really, it's because these technologies make it economical to actually to help companies what they want to do the experiment, collect the feedback, and based on that, make the informed decisions to really produce applications that delight their customers, that help them win the market, that help them create the competitive differentiation that they are seeking. So that's what I think it comes down to. It's all about gaining the competitive or business edge adopting a new way of developing things.
Okay, so I mean, there's another question, which is, hey, I'm trying to get to DevOps, but I've got a monolith that's holding me up. And I think your point there, really, that this is a discipline, it's a way of thinking is important. But what kind of advice can we give to people that are trying to make these migrations happen? They realize there is a business need, there is a business value in time to market, there's a business value in maybe the flexibility, the anti-vendor lock components of Kubernetes as a way of managing their applications. And look, I have seen people deploy things like WordPress in Kubernetes, which is a classic, monolith plus database app, successfully in a Kubernetes environment. So while it's not an ideal solution, it is an operational model that can be used. Right. So is there any guidance that you guys can give to people that are looking at this migration to say, how do I make that transition? We only have a couple of minutes left. So, I mean, Tarak, why don't you start? Where are you seeing the best bang for the buck for somebody trying to say, we need to get faster, we need to get better, and we think cloud native might be the right strategy, right?
Right. So I'll give an example, and I'll keep this quick because I know we don't have time. So I'll give you an example of some work I did at a federal agency last year, and they had a very similar situation. It's a monolithic application. and the processes that we're using were definitely not DevOps. So one of the first things we did as part of this transformation was sort of a process value decomposition. So we outlined the entire process from beginning, like from when the requirement is actually elaborated to the point where the code is deployed in production. So we outlined the whole process, and then we decomposed the process into its individual components. And we did an analysis of where the most waste was happening. So some steps were more efficient than others. There were a few steps that we identified where the most waste was happening. And that's where we focused the most. So one of the processes that we identified was the build process, where a build of the application would take about 4 days. So as part of our initiatives, we created a Tiger team that was focused on optimizing the build process. And we got that down to less than 20 minutes. So now instead of doing a build every 2 weeks, they were doing a build every day, a full build every night, and another build every 2 hours. So that was one process. The other process was the aspects of deployment. So we created separate teams to target the deployment processes and automate some of those portions. The third aspect that we found was they spent too much time debugging the environment as part of the deployments. And the reason we found for that is because they did not have proper instructions on recreating the environments because it was so complex. So we standardized the environments between development, test, and UAT, and to some extent production. And that way, what we did is by automating the creation of the environments, people now did not have to debug these. If for some reason an environment didn't work, it was just easier to recreate it. So we had different Tiger teams focus on different aspects of the problem, and we were able to achieve full DevOps within a year. But I would always start with the process and make sure that you identify the places that need to be worked on first, because not every part of the process needs to be configured. In some areas, need more attention than others.
Yeah. Okay. I think that's a good way of looking at it. Syed, did you have any comments on what you're seeing in terms of sort of that model that works, the repeatability that works?
Yeah, no, so I think to build on Tarek's comments, basically the idea is when people are, identifying certain applications, when we go in, we ask them, look, do you have the baseline? Establish the baseline based on baseline, and then establish the outcome first, and then work backwards. So, okay, I want to do this. I want to be able to recreate this application or update this application in a certain way, or we want to have this much frequency of deployments and things like that. And then work backwards. What do you need to get to achieve that outcome? And that's what we at Red Hat, we do that quite a lot with our services team and things like that, as well as then that's the way we figure out, where, if you need to pick and choose different technologies, if you're using different things that does not give you the capability to achieve the outcome you need, then we also recommend some technology upgrades and things like that. So I think that's where it's all, I think if I have to summarize in 2 words, it's outcome delivery. It's focus on outcome and then work backwards.
Yeah, I mean, the one thing that I would add to all of that is that, if we've done the standardization of process, we've gotten to consistent, development, test, production environments. We've defined our outcomes because our outcomes are driving that, test-driven development, business-driven development sorts of systems models. The one thing that I always find gets missed in all of this is we've got the business defined, we've got the technology defined, we forget to educate the people on how those two fit together, right? Yeah. And a lot of what we do as a company is exactly that. It's help bring those pieces together by educating the developers on how they should be developing, and also the business leaders on how they should be expecting results from those technology decisions that they're making. Yep. Right. And so I think they're putting all those things together. I think we're basically at time. So Tarek, last words, last thoughts, any last thing you want to leave the audience with?
No, I just really enjoyed this discussion, and I actually learned quite a bit from it as well. So I'm just really grateful to be a part of it, and I'm looking forward to working and being part of more panels with you guys.
Yeah, great. And Syed, any last words, last thoughts?
No, same. I think same sentiments. This was, by the way, my first panel discussion, so I was a little nervous, but I think it was a very good discussion. The whole idea is, look, the old adage. I think Mark Anderson said, "Software is eating the world," and it's not a cliche. It's actually true, and you have to become good at producing software applications, because applications that differentiate you cannot be bought. Otherwise, everybody buy Salesforce.com or SAP applications and differentiate themselves. So you have to, ability to build delightful applications is really becoming a critical business capability. So I think that's where cloud native and containers and microservices is all the means to achieving that objective.
Great. Well, I look forward to having a conversation like this again with you guys in the future. I think we really did touch a lot about the shift that's happening in this environment and what cloud native really means. I also learned a lot. So again, thank you guys for joining. Thanks everybody for watching. And if you're watching in the future, thank you for watching in the future. We look forward to having you next time.
Thank you.